All right, hey, welcome back. We are going to talk about isomers and what does that mean and what does it mean for you? This is going to be a little bit of a tricky page for some of you. This is going to be the isomers of heptane. So, Mrs. Davis, this is not in your blue book, but you should try to do these on a separate sheet of paper if you can. My advice to you would be to try to do some ahead of me and then go through and watch me go through them and check your answers. Okay, so we're going to start off with our first discussion about what exactly is an isomer. And I'm going to switch to tablet mode because it makes writing on my screen that much easier. Okay, so an isomer, and yes, it's going to ask me about my auto rotate. Yes, I want to auto rotate. All right, so an isomer is, let me circle that, it's going to have the same molecular formula, right? That tells you the number of every element in the compound of the molecule. And so that's the only thing that's the same. So it's this, well, not the only thing. So it's going to be the same molecular formula, and it's going to have the same, obviously, gram formula mass because it has the same molecular formula. But what's different is going to be the structure. Is what's going to be different. And they're going to have different physical and chemical properties. So this is what's different. Right? The prefix iso means that something's the same, but not everything is the same. If everything was the same, there would be some kind of like EQU as the prefix. But when we pick apart prefixes and we pick apart words, right? Like try to really go with those meanings, right? Iso means isotope, isomer, isosceles, right? There's different uses of the word of the prefix iso. So then in our hint, so this is heptane. So this is the first isomer of heptane. But you have to include the actual just heptane first. Why is it called heptane? Because the prefix for 7 is hept, and it's connected by single bonds, and that's where we get the ane. And there's no branches. So that's just heptane. So now when we draw these isomers, we're going to have 2 with a chain of 6. We're going to have 5 with a chain of 5. And we're going to have 1 that has a chain of 4. So we're going to start with the 2 isomers with the parent chain hexane. So why did I go from 7 to 6? Basically, when you're making an isomer, you're just removing a carbon and you're just going to put it somewhere else. You're making a different structure. It's like playing with Legos, right? I got 7 blue Legos and I have 16 yellow Legos. What can I make with it? And everything, each time I make something, it has to be different. So let's start with our 2 isomers with the parent chain of hexane, right? So hexane, hex means 6. So I have 6 carbons in a row. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, and 6. Right, so I have 2 isomers. So I'm just going to kind of go like this. 2 isomers that have the 6 carbon chain. Remember, I have 7 carbons, so I have 1 carbon to place. Now, where am I going to place it? I cannot place it on the ends because that's just making the same thing. That's just making heptane. So I need to place it on one of those inner carbons. So I'm going to place the first one here. Now the next one I have to place on a different inner carbon. So if I go over to the other one, it's not this one because that's the same thing as the one I drew over here. It's just flipped over. So I'm going to put it on the All right, so far okay? All right, so then let's make sure every carbon gets 4 bonds, right? Because carbon needs to be happy. And this carbon has 4, 4. This one needs 2 more and 2 more. And there we go. And then this one needs 3 more, but I'm just going to make that a CH3. And at the end of every bond is a hydrogen. Right, that's why I drew that CH3 because it just makes it look a little bit neater. But you could just have drawn the little sticky bonds and the H's sticking off of there as well, and it would still be absolutely correct. Okay, so the next thing I need to do is I need to give this thing a name. when you give it a name, I'm going to try my highlighter feature. I'm going to highlight the longest chain. So in this case, apparently it doesn't want to let me highlight. No, I cannot use the highlighter feature. Let's try. No, it doesn't like the highlight feature. Okay, so let's just, I'm going to do a yellow circle instead. Okay, so I'm going to circle my longest carbon chain. Any carbon outside the circle is considered a branch. Okay, so maybe I'll just use this green for my branch here. There's my branch. So then when I give this a name, I need to count the longest chain, which in this case is 6. And the prefix for 6, according to table P, is hex. Now, according to table Q, the bond that's holding everything together is a single bond. Single bonds end with A. So now I have to identify that there's something sticking off of this 6 carbon branch, or 6 carbon chain, I mean. I need to talk about that branch, right? This is my branch. How many carbons are in that branch? I have to count them. 1. So according to table P, the prefix for 1 is meth. But since it's a branch, I'm giving it a YL as the ending. The YL means it's a branch. The meth means it's got 1 carbon. So then I have methylhexane. And now since there's more than one location that 1 carbon can be, I have to give it a number. And since it's over here closer to the left-hand side, I'm going to call this carbon number 1. This is carbon number 2. So then this is 2-methylhexane. So when I take this word and I break it apart, it means on carbon number 2 is a 1 carbon branch attached to a 6 carbon chain connected by single bonds. All right, let's go over to our next molecule. Let's go back to blue. So now making sure that every carbon has 4 bonds around it, I'm drawing all of the bonds, and then just to make it neater. So I'm going to leave off all of those H's just for the sake of time because it's going to just take forever if I'm drawing all of them. So don't forget your H's, okay? All right. So I'm just going to leave them off for now. All right, so when we give this a name, I am going to circle my longest chain of carbons, connected carbons, right? That means if you don't lift up the pen, right? So then when I counted all of those, then how many were there? There was 6, right? So then I had, this is hex for 6, connected by single bonds, A and E. And now I have to say this branch, which has 1 carbon, so I count the number of carbons in the branch, there's 1 carbon. The prefix for 1 is meth, and since it's a branch, it gets the ending YL. Right? Organic chemistry is like learning a foreign language. And now it's on carbon number 1, 2, 3. Count both directions. 1, 2, 3, 4. I want to use the smallest number. So that's going to be a 3. Okay, so if I go back to the top of my page, I have just done the 2 isomers with the parent chain of hexane. So basically I took 1 off of the end and I placed it somewhere else inside the molecule. So now instead of a 7 carbon chain, I went from a 7 carbon chain to a 6 carbon chain. Now I'm going from the 6 carbon chain to the 5 carbon chain. 2 carbons to place. Now we're gonna do those. We have 5 of those. All right. So we have 1, 2, 3, 4, 5 of those with a 5 carbon chain. So then I'm going to do my 5 carbon chain, and I'm going to do 3. All right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm just going to do this with all of the boxes that I have to do with the 5 carbon chain, right? So then 1, 2, 3, 4, 5, right? Organic chemistry is all about listening to Mrs. Davis count out loud, like the count from Sesame Street. Okay, let me make that bond look a little bit prettier. Okay, yeah, I just made it look uglier, so now I have to replace it. My erase function is going to be junky. So there we go. All right. So I took care of my 6 carbon chains. Now I got to do my 5 carbon chains. So I have 2 carbons to place. And I can do it 5 different ways. So the first one I'm going to do is I can't place it on the end. Placing it on the end just makes it a 6 carbon chain. Right? If I stick it down here, then it's not going to be a 5 carbon chain anymore. It's going to be a 6 carbon chain because it would be connected to the rest. It would be connected to the rest of those carbons. So what I'm going to do is I'm going to put 1 carbon here, and I'm going to put 1 carbon here. How's that? So now I have my 7 carbons. Did you get so far? Okay. So then making sure every carbon has 4 bonds around it. And these are 1 carbon branches, so I'm going to just do CH3, right? Because terrible, terrible stylus. You know how it goes, kids. Okay, so now remember, I'm just going to leave off those H's. I'm going to give this thing a name. So I am going to circle the longest carbon chain. Here's my longest carbon chain. And then I have the branches. Any carbon that is outside of my circle is a branch. So I have a branch here and I have a branch here, right? So now instead of 1 branch, I went to 2 branches. So 1, 2, 3, 4, 5. Prefix for 5 is pent. Now it's connected by single bonds, so table Q tells me that that is A and E. Use your reference tables for this. So now I have 2 separate branches. Each one, this is not a 2 carbon branch, because a 2 carbon branch would be a branch that's long with 2 carbons. These are 2 separate little branches. Right? These are 2 little stubby little branches off of the tree. They're not long branches of 2 carbons. They're short branches, each with 1. So I have methyl, right? Because I have a 1 carbon branch. But I have 2 of those 1 carbon branches, so I'm going to put the prefix di. So dimethylpentane. I have to give a location on the 5 carbon chain. Where is each of those methyls? Not just one of them. I need to show you where each methyl is located. So this is carbon number 1, 2, or 1, 2, 3. So it's going to be closer if I call this one number 2. So I have 1 on carbon number 2, and I have 1 on carbon number 3. So that's carbon number 2, carbon number 3, dimethylpentane. Okay, now let's go on to our next one. Going back to my green. Okay, so on my next one, I'm going to put this here. And then now I can't put it on the same one. I'm going to have to put it over here. Right? I'm just finding different places to put those 2 carbons so that I don't make the same molecule twice. So then now every carbon gets 4 bonds, right? And so my branches still need 3 more, so those are CH3s. And I'm going to draw my 4 bonds. Carbon, 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 carbon. All of those carbons. And again, at the end of every one of those lines is an H, but for the sake of time and for your and my sanity, I am not going to draw those. To give it a name, I want to circle my longest carbon chain. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 5 is the longest. There we go. 5. And now I have 2 branches. I have a branch here, and I have a branch here. 1 carbon. Each of those branches has 1 carbon. So again, I have a 5 carbon branch, a 5 carbon chain, table P. Right? I'm going to go from the back of the name forwards. So pent-ane, right? A-N-E because it's constructed by single bonds according to table Q. I have 2 1 carbon branches. So methyl, right? The YL means branch. I have 2 of those. So now I'm going to put that as a di. And now I have to say, where are those located? Exactly. I need to give a location. Just like your house has a house number, these little branches need their own number on their street. So this is carbon number 1, 2, or carbon number 1, 2. So it doesn't matter which direction I count, the shortest number is 2. So I have one carbon branch on carbon number 2. So then if this is 1, 2, that one is 3, and then that one is 4. So 4. Or if I count in the other direction, it's 1, 2, 3, 4. It's still going to be 2, 4. Doesn't matter which way you count. Remember, this is a three-dimensional molecule, or you can flip it over and you can rotate it. So now this is 2,4 dimethyl pentane. All right. So now all we did was take the 2 carbons and we placed them on the 5 carbon chain. So now I'm going to do the next one. So the next set, I cannot make the same molecule. So instead of putting each of the 2 that I need to place on separate carbons, I'm going to put 2 on the same carbon this time. So I'm going to put 1 here and 1 here. And now I can do that over here on this one. I can put 1 here and 1 here. Okay. So now I just made 2 different ones. Now let's figure this whole out. Let's give every carbon their right number of bonds, and let's give these 2 a name. So I still need 3 bonds around these, so that's a CH3. And then I still need 3 here, and I still need 2 here, and here 2, and that one gets 3. Let me just make those a little bit longer. Remember, there's H's at the end of those lines, right, because these are hydrocarbons. And we'll just do this one while we're doing bonds over here. And then we have a CH3 and a CH3. And then here, 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 right? And then H's. Now let's give it a name, right? First, we have to make sure that we find the longest chain of connected carbons that we can find, counting every which possible way. So 1, 2, 3, 4, 5. Okay, that's 5. Count backwards. 1, 2, 3, 4, 5. Now 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Sorry. 5. All these different ways, I counted 5. So I'm in a circle. That's the easiest one to circle. It doesn't matter which 5 you circle, the name comes out to be the same. All right, now let's give it a name. All right, circle my branches. There's my branches. Right, organic chemistry is best when you do it with different colors, I think. So have different colored pens and pencils. I think it makes it easier. I'm visual, so that helps me a lot. So my longest chain is 1, 2, 3, 4, 5. So pent, right? Table P tells me that. Table Q tells me that anything connected by single bonds has an E ending. And now I have a branch and a branch. This is not a 2-carbon branch. These are 2 separate 1-carbon branches. So I have another dimethyl. Well, why isn't it a 2-carbon branch? Well, because this is like 2 different houses. This one is my neighbor across the street, and this is me. It's not the same house. Our houses aren't connected, right? There's a street between us. Okay? Or like the branches on a tree. This branch is on one side of the tree, this branch is on another side of the tree. So now I have to say where exactly on this chain are those 2 carbons. So it's either going to be carbon number 1, 2, or carbon number 1, 2, 3, 4. Well, I want to count the shortest direction, so that's going to be 2. Well, this is not 2-dimethyl pentane. I have to give a location for each of them. I know they're on the same carbon, and it seems weird to you, but we're going to have to say 2, 2. Because when I take this name and I break this apart, that means that on carbon number 2 and on carbon number 2 is a 2 1-carbon branches on a 5-carbon chain connected by single bonds. Okay, so let's go through and let's name and count our other ones. 1, 2, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4. 5 is my longest carbon chain. Circle my carbon chain. Anything outside of my chain is a branch. Are these branches connected? No, they're on opposite sides of the street, right? So each are going to have to get their own house number. Is it going to be house number 1, 2, 3, or house number 1, 2, 3? Doesn't matter. Either way I count, it's going to be 3. So I have again a 5 carbon chain pentane connected by single bonds. I have 2 methyl, right? 2 1 carbon branches, right? The YL means branch. And now they are on carbon number 3. But I can't just say 3. I have to say 3, 3, right? 3, 3 dimethylpentane. All right, the next one's a little bit trickier. So I still have 2 carbons to place, and I have to make it different than the other ones that I've already drawn. Now I'm going to just switch to red here to show you where you cannot draw it. So I cannot put the 2 carbons there, because then it would be the same as this one. So I can't put it there. I cannot put it here either, because then it's the exact same thing as this one, just flipped over. So I cannot do the 2 carbons on the 2 carbons I need to place on the same carbon. So I'm going to have to do something different. So remember I said these were on opposite sides of the street. They were 1 carbon branches. What about making a 2 carbon branch? Let's make a 2 carbon branch. Let's make that in blue. So just to have more room, I'll just do it here and here. Now I have a 2, that's what a 2 carbon branch looks like. Now let's make sure that all of our carbons get the right number of bonds, which is going to be 4. So I have those 4, and remember those are hydrogens at the end of every line. Now let me make sure my branch, those carbons still need to have the same number. So then this one still needs 3, so CH3. This one has 2, it needs 2 more, so CH2. Okay, now let's give this thing a name. So first we're going to count the longest possible chain of connected carbons. So starting over here, 1, 2, 3, 4, 5. If I don't pick up the pen, it's connected. Now backwards, 1, 2, 3, 4, 5. I know it seems redundant to you, but it's the process. So now 1, 2, 3, 4. Now backwards, 1, 2, 3, 4, 5, 6. So if I do that, 6 is my longest chain. I'm going to circle that because I shouldn't have another 6 carbon chain according to my hints, right? Let's give this a name and let's see what we get. So I have 1, 2, 3, 4, 5, 6. Right, so that's hexane. And then this would be my branch. And my branch comes off of carbon number 1, 2, 3, 4, or carbon number 1, 2, 3. So it comes off of carbon number 3. So this is 3-methylhexane. Interesting. Well, if I go back up to the top, I'm going to use red now. This over here was 3-methylhexane. So I just drew the same thing. Well, I can't draw the same thing. I have to draw something different. It has to have a different structure and a different name. This one's the same thing. So this one is going to be long. All I did was make a bent chain here. So I'm going to just do the correct one. What color would I use for correct? Orange. I'm just going to do the correct one right below it here. So then I need the 5 carbon chain. 1, 2, 3, 4, 5. right, so I can't put my 2-carbon branch here because that's the one that gave me this up here. So I'm going to put my 2-carbon branch on this carbon. So I'm going to do carbon, carbon. Now let's go through and put all of the correct number of bonds. Right, 4 bonds to every carbon at the end of every line is a hydrogen. Now let's give this a name. Okay. We need yellow to count. So 1, 2, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is my longest carbon chain, so I'm going to circle my 5 chains. It doesn't matter which connected chain of 5 that you circle because it comes out to be the same as we learned in the one that we did wrong over here. So then I need to now give this a name. So I have a branch, and now there's 2 carbons that come off that branch. So then I have 1, 2, 3, 4, 5 carbons. So the prefix for 5 is pent. And now my ending single bonds ane. And now I have to name the branch. This branch has 2 carbons in it. So it's a longer branch. So it's not a dimethyl because that would be 2 separate 1-carbon branches like that up there. This is a 2-carbon branch, so I have to find the prefix for 2. The prefix for 2 is F. So then I have a YL meaning branch. So this is an ethyl branch. Okay? And now I have to say what carbon that ethyl branch is on. So 1, 2, 3. It's not 3, 3, because that would mean there's 2 separate things on carbon number 3. This is going to be 3. Okay, so then if I go back up to the top of the page, now I've taken care of my 5 isomers heptane. And if you're feeling frustrated, don't worry about it. Right? You're not going to be expected to do this on the final exam or the Regents exam. You're expected to maybe just draw 1. But if I show you all 9 of them, you're going to be able to easily just draw 1 of them. Right? If you can do the hard ones, you can just do the easy one. All right? Or you may just need to recognize an isomer. Right? This is about the process, right? It's a mental process. That's what organic chemistry is. Right? This is why, a lot of people go on into college and they have trouble with organic chemistries because they don't want to think and use logic and reasoning. They just want to memorize stuff or just do some math formulas. Well, you can't do that with organic chem. Okay, so let's pick, I'm going to try this lavender. I haven't used that. Let's do our 1 isomer with the butane, right? Bute means 4. So now I'm going to do one with a 4-carbon chain. It's our last one. So our 4-carbon chain. So 1, 2, 3, 4. All right, so 4-carbon chain. So now remember, I have it's C7, H16, right? I've got how many hydrogens? I've got 4 carbons. I have to place 3 carbons on this one. I can't place them on the ends because that just makes a longer chain. I got to place them on the inner carbons. So I can place 1 here. There's 1 out of the 3. Okay, now 2 out of the 3. And now I'll just do the 3rd out of 3. There we go. I placed 3 carbons. And now making sure every carbon gets 4 bonds. 1, 2, 3, 4. Now I'm going to just do that as a CH3 and a CH3 and a CH3. And then that still needs 1. And that still needs 1. Be careful when you're drawing the bonds, okay? Because if you forget one little line, you get the question wrong on the Regents exam or the final exam or test, right? You want to make sure that you're being careful and you're paying attention to the details because it's all or nothing. It's structure and the name are either right or wrong. No partial credit. So now let's count our longest chain. I have 1, 2, 3, 4. Backwards, 1, 2, 3, 4. Now let's count the other directions. 1, 2, 3. 1, 2, 3, 4. Now backwards. Oh, wait, 1, 2, 3. Now it's backwards. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 4 connected carbons is my longest, so connect. Those are my 4 connected carbons. And now I have a branch. Anything outside of my connected carbons is a branch. I've got 3 branches. They all have the same number of carbons. So then I have 3 methyl branches on a 4 carbon chain. So 4 carbons is bute, and then the single bond ending ane. And now I have 3 methyl branches, right? So the prefix for 1 carbon is meth, and then YL indicates it's a branch. And I have 3. So it's not going to be dimethyl. It's going to be, well, if we have something with pedals and wheels, and 3 of them, it's a trimethyl pentane. Now let's give numbers. Is it going to be number 1, 2, or 1, 2, 3? So I'm going to call this carbon number 1 and this carbon number 2. So then I have 2, 2, 3, right? Each one needs a number. 2, 2, 3, right? So 2, 2, 2, 3, trimethylbutane. Okay? So that wraps up our isomers. And remember, CnH, 2n plus 2, right? These are all alkanes. So they all meet, right? So C7, right? If N is 7, the hydrogens are going to be 7 times 2 is what? Okay, 14 plus 2 is 16. So if I go back and I count all the carbons and hydrogens, they're all going to have the same molecular formula, but they all have different structures and different names and different physical and chemical properties. Okay, so the main goal of this is naming, drawing, and recognizing an isomer, not whether or not you are able to draw all 9. All right, until our next video, I will see you next time. And remember to practice.